Welcome to this tutorial on simulating a rigorous distillation column in DWSim. In this tutorial, we will learn to simulate a rigorous distillation column, specify column pressure profile, specify tray efficiencies, check desired product compositions, and view the column profiles. This tutorial is recorded using DWSim version 5.8 Classic UI Update 3 and Windows 10 OS. But this process is identical in Linux, Mac OS X, or Fussy OS on ARM. To practice this tutorial, you should know to add components to a flowsheet, select thermodynamic packages, add material and energy streams, and specify their properties. The prerequisite tutorials are available on this website. You can access these tutorials and all the associated files from this site. Shortcut -end file used in this tutorial is provided as a code file on this tutorial page. Download the file from code files link. I have already opened DWSim on my machine. I have opened the file shortcut -end.dwxmz. Let me save this as rigorous. We can see that the file name has changed now to rigorous. Click on the Settings button on the toolbar. Click on System of Units tab. Locate Pressure menu on the right-hand column. Click and choose ATM for atmosphere. Press Enter. Similarly, change the units of delta P to ATM. Press Enter. Close the settings window. Let me switch to the slides. This problem was solved in the spoken tutorial on shortcut distillation. These values form the basis for the rigorous distillation column problem. This represents the solution of the given problem using shortcut distillation. We will be using this value shortly. Let us begin by replacing the shortcut column with a rigorous column. Let me go back to the simulation. Right-click on the shortcut column and select Delete. Click Yes in the prompt box. At the bottom of the main simulation window, go to Columns tab. From the displayed list, drag and drop a distillation column to the flowsheet. Let us now arrange it as required. Click on the distillation column. On the left, go to the Property Editor window of the distillation column. Now, under Column Specs, click on the General tab. Locate the Number of Stages option. We have to enter the total number of trays here. We got the equilibrium stages to be 20 from the shortcut method. We can see it in the slide. Let us go back to DWSim. This number should be one more than the equilibrium stages given by shortcut method. So, change the number of stages to 21 and press Enter. This number includes the condenser also in DWSim. So, here we will use a total condenser. Now, we will select the solution method. Click on the drop-down against Solver. Choose the solver as wang-henke bubble point if not already selected. By default, wang-henke bubble point is already selected as solver. Now, we will connect the streams to the distillation column. Go to Column Configuration section. Navigate to Connections, Stream Connections, Feeds. Here, we have to specify the stream which is entered as a feed to the column. Here, we can see the list of feed ports. Select any port where we want the feed to enter the distillation column. For a better look, we select column feed port 5. Click on the drop-down against column feed port 5. Select feed and press Enter. In a similar way, we will connect the product streams. Now, click on the Products tab. Select Distillate as Distillate and press Enter. Select Bottoms as Bottoms and press Enter. Now, we will connect heat duties to reboiler and condenser. Click on the Duties tab. Select Reboiler duty as R duty and press Enter. Select Condenser duty as C duty and press Enter. Now, under Connections, click on Stream Stage Associations tab. For feed port type, select stage location as Stage 9. Press Enter. This is as per the solution we got in the shortcut distillation column. We got the optimal feed location to be 9 from the shortcut method. We can see it in the slide. Let us go back to DWSim. This completes the connection. Now, we have to provide the top and bottom specifications. Under Properties tab, locate the section Column Specs. Click on the Condenser tab. Select Condenser type as Total, if not already selected. By default, it is Total Condenser. We will leave it as it is. Change condenser pressure to 1 atmosphere and press Enter. Select condenser pressure drop as 0. By default, it is 0. We will leave it as it is. Next, select the specification as Reflux Ratio, if not already selected. By default, Reflux Ratio is already selected as Specification. Under Compound, we can see a field. Here, we can enter the value of reflux ratio. We will enter the reflux ratio as 2.317. Press Enter. Now, click on Reboiler tab. Change reboiler pressure to 1.1 atmosphere and press Enter. Select specification as Product Molar Flow, if not already selected. Under Compound, change the units to kilomole per hour and press Enter. Now, enter the molar flow rate as 60.204. Press Enter. This is suggested by the shortcut solution. We can see it in the slide. Let us go back to DWSim. Now, we will also see how to specify the pressure for the intermediate stages. Now go to Column Configuration section. Click on Stages tab. It shows the condenser and reboiler pressures as 1 and 1.1 atmosphere. New stages that have been added are assigned 0 pressure, which is incorrect. We would like the intermediate stage pressures to take the interpolated values. Under Column Configuration section, go to the extreme left. Here we can see 5 different icons. Hover the mouse to the last icon. A pop-up is displayed as Estimate Stage Pressures by Interpolation. Click on the icon. Immediately, linearly interpolated values are assigned to every stage. We can also edit the pressure of the individual stages if they are known. We may also change the efficiency in one or more stages. Now, we will run the simulation. Click on the Solve Flowsheet button on the toolbar. When the calculations are completed, click on the Distillation column. Go to the Property Editor window of the Distillation column. Locate the Results section. This shows all the required results like condenser duty, reboiler duty, and column profiles. Now, let us look at the column profiles. Click on View Temperature, Pressure, and Composition Profiles button. Now, we can see a pop-up window. Here, we can see the temperature profiles, flows profiles, component flows, and component fractions. For the exact number, click on the Table tab to the right of the Graph tab. Now save this file. Let us summarize. In this tutorial, we have learned to simulate a rigorous distillation column, specify column pressure profile, specify tray efficiencies, check desired product compositions, and view the column profiles. Take the assignment from the shortcut distillation column. Perform the simulation using rigorous distillation. Here is the assignment problem statement of the shortcut column. With this, we have come to the end of this tutorial. Watch the video available at the following link. It summarizes the Spoken Tutorial project. The Spoken Tutorial project team conduct workshops and give certificates. For more details, please write to us. Please post your time queries in this forum. The FOSSEE team coordinates conversion of existing flowsheets into DWSIM. We give honorarium and certificates for those who do this. For more details, please visit this site. The FOSSEE team helps migrate commercial simulator labs to DWSIM. We give honorarium and certificates for those who do this. For more details, please visit this site. Spoken Tutorial and FOSSEE projects are funded by NMEICT, MHRD, Government of India. This tutorial was originally recorded by Professor Kannan Moudgalya in September 2015. This is Kaushik Datta from IIT Bombay. Thanks for joining.